So when we were talking about this before, we were saying about can something be caused by another, or causation. And a lot of people got this incorrect on the test. Does one thing cause another? And when we were talking about correlation, we said just because something is strongly correlated, or like even has a correlation of 0.99, which we know has a positive, strong, real strong linear correlation, it doesn't say, we can't say that these two things cause each other. But when we use studies, that's kind of the goal. And there are two different types of inferences, we're going to call them. There's two different types. And this is where you can infer that something will work or will not work based on a treatment. And for the first one, we're going to talk about inference about the population. And the second one we're going to talk about is inference about cause and effect. So an easy way to kind of think of this, because it gets kind of confusing to tell between the two, and on the AP exam you'll have to kind of explain which one is which. This is like the census. Okay? You can ask a small randomized sample from the population, and the data that they receive can give you more of an idea about the population. So you can infer about the population based on the census data. And even that, I'll show you the community survey that comes out too, and that asks more questions about the population. And they do this randomly throughout everyone who lives in the United States of America to get more information about the population as a whole, even though they're not asking the whole population. An inference about cause and effect would be like a very good experiment. And something where you choose who's going to receive the treatment. And of course we need a control group. I don't know why, don't ask. And this is random of how you select those people. A really good experiment, if I want to take a certain drug for headaches or drug for blood pressure, I want to know that they did an experiment where they gave some people this drug and some people a placebo. And I want that to be random, and I would like it to be double blind, where nobody knew what they were receiving, and record the results. And then I would consider it. You haven't copied down this chart from page 262. Why don't you do so now? Because this is a good idea to see if you can infer that something is an inference about the population or cause and effect. So if individuals are randomly selected, okay, let's have a space for yes and a space for no. Then In order for the individuals, in order for it to be an inference about the population, the individuals must be randomly selected. So they have to be in this yes column to have a yes. If they were not randomly selected, then we can't make an inference about the population. And another thing that we should add is, were individuals randomly assigned to groups? And let's put a yes here and a no here. Were they randomly assigned to the group? Okay, so if yes, we're going to go in this direction, then you can make an inference about cause and effect. This causes that. The blood pressure pill caused the blood pressure to lower. Now, no matter what, because we're in this yes column, regardless of whether the individuals were randomly selected, yes or no, the inference about cause and effect is going to remain the same, because the people were assigned to the groups randomly and typically didn't know which group they were in. So if they were not assigned randomly, then the inference about cause and effect would be no, if they were in that area. And to further this about the population, if the individuals were randomly selected, can you make an inference about the population? Yes. You can also make an inference about the population even if the groups were not randomly assigned. And can you make a reference about the population, an inference about the population if they were not randomly selected? Then no. And you might want to copy the actual chart from page 262. That might be helpful. But what's it based upon is, when you go up here, let's add this. Inference about the population, individuals are randomly assigned, and inference about cause and effect. A randomized experiment would mean you have groups randomly assigned.